Hello everyone. This is my pattern recognition project on the topic comparative study of spam filtering algorithms. I have done this project in a group. I implemented three algorithms, and so did my groupmate Ankur. And then we combined and compared the results of all the six algorithms. So just let's jump into the topic. Uh, in the introduction, I was like, in the last decade or 2 decades, email system has just one of the greatest invention. They're fast, not too informal. Apart from communication, there are many other purposes. It can be used for other like fraud. Like it is said, happiness come at a price. So it opens door to people like with malicious intent who would use this medium on World Wide Web for wrong purposes like cyberbullying, money fraud, and other cybercrime, which is our main topic, like email spam. Uh, Email spam, also known as junk mail, is a subset of electronic spam involving nearly identical messages such as sent to numerous recipients by email. They not only waste user time but also waste users' bandwidth, or we may say dial-up connection, which cost user money. Um, Technically, they are like unsolicited bulk of mail, which are which is the activity of sending unwanted email messages with commercial intent. Like many companies sent a bulk of messages to the recipient. The email addresses of these users are collected from different sources, like in the form of social mediums or even crawling through web. Now, it has many types. It can be a spam word type sites. It can be Nigeria 419 scams. Can be a phishing attack, like either you receive people receive a mail, you have won a lottery, you have won a jackpot, click on it, or send a bank detail. Email spoofing, antivirus spam, like you will receive when you open a particular page, you receive like you have a particular virus, install this particular antivirus, and when you install it, it causes malicious intent to you. There are commercial advertisements. These are not that harmful, but it's kind of irritating when you receive in a bulk of them. So, over a period of time, large importance has been given to email spam filtering. Companies are coming up with ways of categorizing spam emails so that users do not fall in the traps discussed. Many even Gmail and Yahoo have separate folders for advertisement promotions folder, so that user don't get irritated so easily, so that he can just sort out his personal emails separately from them. And we have a spam folder which automatically deletes some spam mails over a period of time. Now, coming to spam filtering algorithms. Okay. Many algorithms of data mining are devised to filter these, but which one is better? Like the question remains, which one is better? Uh, a lot of work has been done in this field, but it has been done on the basis of efficiency and performance. What our project is about is like to compare all the renowned algorithms on the basis of error rate and false positive ratio. We have taken Navebase, Vinode, SVM, KNN, AdoBoost, and Perceptron into consideration. Now, for the related work, I read a paper like regarding this was one of the first papers regarding spam that was introduced by uh, in 2002. It was like to familiarize user with the idea that a spam kind of thing exists. Um, there it was sorted like in 2003. It was proposed, like the same author proposed, it can be sorted out using the Bayes theorem. In 2013, a comparative analysis of context-based spam filtering was done. It compared the basis of error rate and execution time, but did not consider the false positive ratio. So this is a project all about. The terminology that we are going to use in this project was is like ham mail, which is not spam. That is a normal mail. That is personal. That can be personal, but not a spam. False positive. In a case, false positive is a scenario when message is designated as spam, where it was a legitimate ham. Execution time. time taken for a particular algo to execute. That's simple. Now, the algorithm that I have implemented are the naive-based support vector machine, that is the SVM, and the Winnow. The other three algorithms are implemented by Ankur, which are present in his report and presentation. Now, coming to the naive-Bayes algorithm, uh, it was created by Thomas Bayes, proposed the idea of Bayesian classification. The idea was based on statistical and probabilistic method of learning. Naive Bayes is a type of SLA algorithms. Now, SLA can be defined as an algorithm which interprets result on the basis of trained set of data. Uh, Naive Bayes is based on conditional probability. Conditional probability can be defined as the occurrence of an event after happening of another event. Now, this is a simple formula of the Bayes theorem. Now, what I have taken into consideration is like we have implemented the naive-Bayes classifier of binary domain, where in this formula that we have used to create the error, calculate the error rate, where xi is the ith word to be classified of a message. WH occurrence of a word in ham mails. WS occurrence of word in spam mails, and similarly SP mails that are spam in training set. Now the results that we obtained after the implementation was like when we considered a 1:1 ratio of spam and ham for a data set, the error rate was around 7.5 to 7.6% and 3% of false positive ratio. Now, when we changed to a dataset that we used that from CS mining uh, to 3:7, like the 3% will be 30% was spam and 70% was ham. The error rate is degraded by 1.5%. There is also reduction in false positive ratio by 0.8%. That's good. Now coming to the support vector machines. Support vector models belongs to supervised learning models that identify pattern and then analyze them. The SVM classifier divides data into vector actually of two distinct types, that is regular or spam. Tokenizing works same as naive, but instead it uses vectors to calculate word frequencies and the corresponding token code. Here in the diagram you can see like it's giving the workflow of the SVM. It collects mails, separate to tokens, calculate the word frequency, define token code, and make vectors and construct filter for it. That's the pre-processing, and then the classifying, like to separate to tokens, define vector from mails, and classify by SVM filter. We I implemented this like there is a MATLAB inbuilt function for SVM. We use a reduction factor, artistic factor. For all the algorithm, we consider a tested fraction of 0.5. But for SVM, we have to consider it 0.4 point 0.4 because the code used to crash when we were using 0.5 actually. So we got an error rate of 5% and false positive ratio of 4.5%. It gave the same ratio of false positive and false negative. So it was like the second best algorithm that we implemented. Now coming to the winnow. And the winnow algorithm is a non-probabilistic algorithm but a statistical. Winnow extract all the content of dataset character by character and regular expression is used to tokenize. Then these tokenized words are taken in sets and give as an input to the Winnow network. Features are extracted from consecutive files, read, and are then compared to the features that are present in the existing network. Similarly, we can see the workflow of the Winnow. Like in pre-processing, you collect mail, extract word by word, separate to tokens, accumulate in grub as input. Now, when you're classifying it, you the separate to tokens, test the input mails with the existing network, update the network, classify the Winnow algo. Now, the results for the Winnow was pretty good. Like if there was an increase, we multiplied by 2, and if there was a decrease, we multiply by 0.5. So that got us the error rate of 17% and the false positive rate of 6.8%. To have a small amount of false positive ratio, I had to use asymmetric factors of 0.125, which got me a false positive ratio of 4.4% and an error rate of 19.3%. So these are the conclusive results after combining all the six algorithms. Like Naive Bayes and the SVM were the best, but Naive Bayes was much better. This may also depend on like the data set actually. So it might change with the change of data set. So in the next video, I will be giving the demonstration of my codes. Thank you for listening.